In this question asked which of the following electronegativity order is incorrect. So the first option is given as aluminum less than, magnesium less than, beryllium less than nitrogen. So if you see the electronegativity values on Pauling scale, so we know that the nitrogen having the electronegativity on Pauling scale as 3. Electronegativity has the no units. And the second one, boron is having the electronegativity as 2. And magnesium is having the electronegativity value as 1.2. And aluminum is having the electronegativity on Pauling scale as 1.5. So the correct order of electronegativity is nitrogen greater than, boron greater than, aluminum greater than magnesium. But in this one, aluminum less than magnesium is given, which is the incorrect option. Option 1 is the correct answer for this question. Here the lanthanides ions with 4f7 configuration are. So here europium is given, gadolinium, europium 3+, terbium 3+, samarium 3+ are given. You have to identify the electronic configuration of these elements. So if you see the europium atomic number is 63. For this one, you have to write the europium 2+ configuration. So it is xenon 4f7 6s0 configuration. So it is having 4f7 configuration. So now if I am going to take gadolinium. So if you write the gadolinium configuration, atomic number of the gadolinium is 64. So the configuration of gadolinium 3+ is xenon and 4f7 5d0 6s0 configuration. If you write the electronic configuration of europium 3+, it will be 1 electron less from 4f7. Then it having the configuration xenon 4f6 configuration. It is not having 4f7 configuration. If you write terbium atomic number is 65. If you write the terbium 3+ electronic configuration, xenon 4f8 6s0 configuration. It is not having 4f7 configuration. If you write samarium 2+, samarium atomic number is 62. Its electronic configuration is xenon 4f6 configuration. So out of the species given, 4f7 configuration is there for gadolinium 3+ and europium 2+. Both are there on option 1 is the correct answer for this question. Here the match the list 1 with the list 2, aluminum 3+, magnesium 2+, Na+, and F-. We know that all these are isoelectronic species. Isoelectronic species, which one is having the more size means the species which is having high nuclear charge is having low size. That's why Al3+ is having small in size and F- is having more size. All these are isoelectronic species with 10 electrons each. So the correct order for this particular A is 4 because it is matched with 4 ionic radii. And the next one, boron less than, carbon less than, oxygen less than, nitrogen. We know that nitrogen is having half-filled electronic configuration 1s2, 2s2, 2p3 due to the presence of half-filled configuration. Nitrogen is having high ionization potential when compared to oxygen. Oxygen is having high ionization potential when compared to carbon, when compared to boron. So it is the order for ionization potential. So B is suitable for 1. Now boron less than, aluminum less than, magnesium less than, potassium. It is one order given. For this one, the order is, the correct phenomenon is Potassium is having more metallic character when compared to magnesium, because potassium is a 1A group element and magnesium is a 2A group element, and then aluminium, that is a group 13 element, and boron also group 13 element. For groups top to bottom, ionization potential, metallic character increases. That's why aluminum is more metallic when compared to boron. So the correct order for this one is 2. So C matched with the 2. And the last one, silicon, phosphorus, sulfur, chlorine. We know that chlorine is more electronegative when compared to sulfur. Sulfur is more electronegative compared to phosphorus. Phosphorus is more electronegative when compared to silicon, because all these are third period elements. From left to right, electronegativity values are going to increase. That's why D is matched with 3. So A4, B1, C2, D3, it is there on option 3, which is the correct answer for this question. Which of the following acid is a vitamin? We know that if I am going to take vitamin C, whose chemical name is called as ascorbic acid. The deficiency of vitamin C, ascorbic acid, which leads to the disease called as scurvy. So ascorbic acid is there in option 3. Saccharic acid, which is obtained by the oxidation of glucose by reacting with the concentrated HNO3. Aspartic acid is an amino acid. Adipic acid is a dicarboxylic acid. Option 3 is the correct answer for this question. The radius of the first hydrogen state of the helium is given as. So clearly we know that radius of the nth orbit Rn is equal to A0. In place of R0, you can write A0 into n square by Z. So for helium ion, it is nothing but He plus, the value of Z is taken as 2, and the first excited state it is nothing but the n value is taken as 2. So R2 is equal to A0 into 2 square, 4, by the value of Z for the helium is 2. So here it will be cancelled 2 times, it will be equal to 2A0. It is around option 4. 2A0 is the first excited state radius for the helium ion. So option 4 correct answer for this question. Which of the following electrolyte can be used to obtain H2S2O8 by the process of electrolysis? So if I am going to take 50% H2SO4, 50% H2SO4. So if I am doing the electrolysis of 50% H2SO4, then H2SO4 is get dissociated as H plus and HSO4 minus. HSO4 minus. So this HSO4 minus is an anion which attracted towards the anode, which will undergo the oxidation process at anode, gives rise to H2S2O8 with the liberation of the 2 electrons. This H2S2O8 is called as Marshall acid or peroxydisulfuric acid. So which is obtained with the oxidation of HSO4 minus, which is obtained from this H2SO4, which is taken as a 50% H2SO4. This 50% H2SO4 is taken as concentrated H2SO4 solution. So by the dilution of the sodium sulfate, you can get oxygen gas at the anode, which is not a correct answer. Diluted solution of sulfuric acid also you can get O2 gas at the anode, which is the wrong answer. So option 3 is the correct answer for this question. Arrange the following solutions in the increasing order of their boiling point. So if I am going to take a diluted solution, for diluted solution, if the concentration is more, then vapor pressure will be low. If the vapor pressure is low, then boiling point is high. Whenever the concentration of the solution is increases, boiling point is going to increase. That means the number of solute particles increases for the diluted solution. The colligative property, nothing but the elevation in boiling point, is also going to increase. So here 10 to the power of minus 4 MnACl, here it is urea, 10 to the power of minus 3 m NaCl, 10 to the power of minus 2 m NaCl. So here, given that the three solutes are NaCl here, NaCl, NaCl, NaCl. NaCl is an electrolyte which has been dissociated as Na plus and Cl minus, which is a strong electrolyte. So it can give the two ions. That's why the want half factor for the NaCl containing diluted solutions can be taken as 2. But urea is a non-electrolyte. It is a non-electrolyte. So all these are having the order of the concentration as, for the fourth one, the concentration 10 to the power of minus 2 is high, and multiplied by the effective ion concentration to get the effective ion concentration for the NaCl, you have to multiply with the 2. So the fourth one, NaCl, is having the effective ion concentration as 2 into 10 to the power of minus 2. For the third one, 2 into 10 to the power of minus 3, because I have to multiply the I factor. For the first one, 2 into 10 to the power of minus 4. And the urea is a non-electrolyte which is not going to produce any type of ions. So whose want half factor is 1, then effective ion concentration is 10 to the power of minus 4 only. So out of all these, the concentration is more for 2 into 10 to the power of minus 2. Then its boiling point and the elevation in boiling point is high. So 4 is greater than, and then 3, and then 1, and then 2. That is the correct answer for this question. So 4, 3, 1, 2. 4, 3, 1, 2. It is an option 1, which is the correct answer for this given question. From the magnetic behavior, NiCl4 minus paramagnetic and NiCO 4 times diamagnetic. Choose the geometry of the given complexes along with the oxidation state. So we know that NiCl4 minus nickel oxidation state is 2 plus, and it will be 4s03d8 configuration for the nickel 2 plus. So here chlorine is a weak field ligand, and in the presence of 4 ligands, weak field ligands, the d orbital has been split into the two levels. One, it is called as easy level, and here it will be called as T2G level, and here it will be 1, 2, 3, 4, 5, 6, 7, 8, and no d orbital is empty here. That's it, which will undergo the sp3 hybridization, and the shape of that particular complex is tetrahedral. If I am going to take NiCO 4 times, nickel is in 0 oxidation state, 4s2-3d8 configuration. So it will becomes 4s0-3d10 configuration. Here also no d orbital is left to undergoing the hybridization. That's why here also sp3 hybridization tetrahedral. So both the given complexes are sp3 hybridized with the tetrahedral geometry. So the correct option for this question is square planar wrong, square planar, tetrahedral and tetrahedral, nickel 0, 2 is correct. Option 2 correct answer for this question. In this question, in Carius method for the estimation of the halogens, 180 mg of organic compound produced 143.5 mg of AgCl, percentage of chlorine in the given compound is. We have the formula, percentage of chlorine is equal to 35.5 by the weight of AgCl, here it will be Ag108 and chlorine 35.5, 143.5 into weight of AgCl produced by weight of organic compound taken into 100. That will be equal to 35.5 by 143.5 into the weight of AgCl at that time, 180 into 10 to the power of minus 3 by the weight of organic compound, the weight of AgCl is 143.5 into 10 to the power of minus 3. The weight of organic compound is 180 into 10 to the power of minus 3 multiplied by 100. If you are doing this calculation, you can get 19.72. It is a numerical question. We have to round off to the nearest integer, that will be equal to 20. Is the correct answer for this question.